Hey guys, Jessica again with another Parallax project of the week. So you finished all of your activities in your Want Some Microcontroller Kit, and you figure there's nothing else that you can do with it unless you buy additional parts, right? Wrong. Just like in a bicolor LED memory game, this project of the week only uses parts found in the Want Some Microcontroller Kit. Let's get started. This week we're going to make a simple 1 to 9 minute timer using a 7-segment LED, push button, potentiometer, and piezo speaker. The user will turn the potentiometer to set the number of minutes, then press the push button to start the timer. As time counts down, the display will change, and when time is up, the piezo speaker will emit a tone. As always, full documentation and source code can be found on forums.parallax.com, Stamps in Class mini projects, build your own mini timer. Here you will find all the information needed for completing this project on your own. This project is also a great lesson in making the most of your breadboard real estate. We're going to need a lot of components for this project, and fitting them all onto the board is going to take some creativity. Think of it as a puzzle. Each piece has its own place, and you'll just have to do some thinking to fit it all together. Once we have everything wired, we're going to want to make sure we have everything wired correctly. Now the program testcircuit.bs2 is going to test each aspect of our circuit in one shot. First, the program will play a sound from the piezo speaker. Then the numbers 0 through 9 will be displayed on the 7-segment LED. And finally, it will monitor the push button states and the decay time of the potentiometer. When testing the potentiometer, make a note of the range of values. We'll need this when determining the decay time increments between each minute. Next step. We'll want to figure out how much we want the decay time of the potentiometer to increase between each minute interval. Now this is going to directly relate to when the user rotates the potentiometer to set the number of minutes for the timer. You can do this by taking the total range of decay times and dividing it by 10 for the total number of minutes, 0 to 9. So say you do this and you get a decay time of 59. Now this means that you want the decay time of the potentiometer to increase by 59 in between minute 0 to minute 1. Now these values can also vary from pot to pot, so you want to make sure you do this calculation for your potentiometer. Once you've calculated your decay time increment, we'll want to test that the numbers change when you rotate the potentiometer. We'll do this using lookup and lookdown commands. The lookdown command compares the decay time of the potentiometer to the values listed in its table. These are your calculated incremented values from before, and then decides which number in the list the variable time is smaller than. It then loads the entry number, 0 through 9, into the variable index. The lookup command then uses the index value to choose which binary value to load into the ouH variable. This changes the LED display. Rotate the potentiometer and verify that the numbers cycle from 0 to 9. Now that we know our circuit is wired correctly and the LED display cycles from 0 to 9, we're ready to complete the final program. First, a tone will play, letting us know the board has been turned on. Then, the program will wait for the user to enter the desired number of minutes and start the timer when the user presses the push button. Once the button has been pressed, we can calculate the number of 1-second intervals needed by multiplying the number in the variable index, which correlates to the number of minutes, by 60. We then have another loop that continues for the number of 1-second intervals. In the loop, the program pauses for 990 milliseconds, and then there's another lookup and lookdown table, so the 7-segment LED display will change as the minutes tick down. Once the time is up, a tone will play, letting the user know that their time has expired. This tone can be customized to anything you want, so it's time to get creative. Now really, this isn't the most accurate timer in the world. It can be off by a second or two, but it can make you the hero of your next game night. Just think, instead of assigning someone to watch sand trickle through an hourglass, and really anyone can take out their cell phone for a timer, you can impress everyone with your sweet design skills by whipping out this bad boy. Just think how complicated this wiring must look to the untrained eye. You'll instantly increase your geek cred and maybe even earn yourself a sweet nickname like Boy or Girl Genius. As always, full documentation and source code can be found on forums.parallax.com on the Stamps in Class mini projects page. Until next time, happy developing!